Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're going to take a look at something for the Commodore 64 that I think is really cool, and it is the Kawari, or the VIC-II replacement that's based on an FPGA for the Commodore 64. And it's not just a simple replacement to get you back up and running. There's actually something that is super cool about these boards that I want to talk about a little bit more. So without further ado, let's get right to it. Before we get started with the video, I want to make a little announcement. I'm going to be at 3 upcoming vintage computer festivals. The first one is at the end of July in Atlanta. That's VCF Southeast. Then after that, I'm going to be at the VCF West in San Jose. And then after that, I'm going to be at VCF Midwest again, and that is in Chicago. I'll have all the dates on screen here because I don't remember them off the top of my head. But like all the VCFs I go to, if you want to come meet me in person, well, go find me at those shows. For the first time in my life, I'm going to be giving a talk on stage, just myself, and you can find me doing that at VCF Southeast in Atlanta and also at VCF West in San Jose. In San Jose and in Chicago, I'll be doing the YouTuber Roundtable as well, like in previous times, so if you've enjoyed those sessions, well, come check those out as well. That's it for the announcements. Let's get back to the video. What you see on the bench here is my Commodore 64 in a VIC-20 case. I call it the ZIF-64 if you're not familiar, and that's because I've replaced a lot of the sockets, as you can see, with zero insertion force sockets. That's for ease of troubleshooting, of course, because I've done lots of repairs on 64s over the years, but that's not really the focus of this video. This chip is right here. This right here is the VIC-II chip, and I have an MSI heatsink on it. I salvaged off an old motherboard at some point, but underneath here is a regular NTSC R8 version of the VIC-II. This chip has been very reliable, and I have to say that generally the chip is reliable, but these do fail sometime. And of course, being the video chip and the clock generator for the 64, it's definitely an essential part of the computer. When you remove this from the motherboard, the computer does not work at all. If you have a broken one of these chips, you'll find that to get a replacement is now starting to cost quite a bit of money. In fact, you're probably better off just trying to find a parts machine not working 64 and hope that the video chip is good in there versus buying a single one of these that's tested. In addition, this is the NTSC version. As I mentioned, it's the R8 variant. There is, I think, one other variant in the US, the R56. Maybe there's actually an R7 as well. I don't quite remember off the top of my head. But the R56 version has, well, worse image quality, and the R8 to me is the best, but even this has some issues. We'll talk about that more in a second. If you're in any country other than the US, Mexico, Canada, Japan, and maybe a couple other places, then you're going to have the PAL versions of this chip, which has a slightly different part number, and there are a couple different versions of that chip as well. You cannot just simply take the PAL version of this chip and stick it into this motherboard and have a working system. Now, this will vary a little bit depending on which version of the 64 you have, but this section of the motherboard on this version is the clock generator and the video circuitry. If you're not familiar with 64s, these chips get quite hot in normal operation, hence the need for this heatsink. Well, I mean, I don't know about the need for the heatsink, but hence why I have a heatsink on here, because that just keeps this chip a little bit cooler. Back to the motherboard though, this right here is the crystal oscillator. This needs to be changed if you're going to go find a PAL version of one of these chips to put in the motherboard if you want to run PAL software. There was actually a project on Retro Recipes to have a circuit board that you put on your motherboard that would contain 2 crystal oscillators and 2 VIC-II chips along with some relays to switch between them to allow you to kind of switch on the fly between PAL and NTSC. The reason why PAL is something that you want to consider if you're a Commodore 64 user is because a lot of newer software, games, and demos don't run on NTSC machines at all. The reason why there's even a difference is that PAL refreshes the image at 50 times a second versus 60 for the NTSC version. That actually gives a little bit more time for the CPU to do computational work in between the frames. And these modern games and demos push the system to the very limit, and they're using every last cycle available to the processor to pump out as many computations as possible to make the really amazing graphics and sound that these modern things have for the 64. Now, I wasn't a Commodore 64 user back in the 80s, I was an Apple II user, but I think for people who were using the 64 in NTSC countries back in the 80s, back when this machine was contemporary, there were some games and demos that you got even then that didn't work properly on NTSC machines, and that was probably somewhat frustrating. The Super Mario Bros. Clone, the Gianna Sisters series, I'm pretty sure didn't work properly on NTSC machines. You'd get some graphical corruption and whatnot while the game was running. So that's just one of the examples of, even back then, the whole NTSC PAL thing was a bit of a problem. There are also other subtle issues on the 64 when it comes to PAL versus NTSC. Another thing is that the PAL machine actually runs at a slightly slower clock speed, so music that is designed for a PAL machine will actually sound slightly off tune when played on an NTSC machine. Another issue with the music playback is, depending on the way the software routines are written, the music can actually play back faster, a little bit faster, on NTSC machines. Now, if you watch my 8-Bit Dance Party, which I played a million times, I'm usually playing that back on NTSC machines because, of course, that's what I have the most access to. And if you ever play the original Donkey Kong arcade game, you'll notice that it's playing too fast and the frequency is slightly off. Now, I'm totally used to the way that music sounds now, so when I listen to the original PAL version, the way it's supposed to be written, the way it was composed, it actually sounds a bit too slow to me. And I think back in the day, if people here in North America were running games that were designed in PAL markets, well, you didn't really know any different about the music, so you were just used to the way the tempo and the frequency sounded, and that was the normal for you. But nowadays, if you're really into the 64 like I am, and you're trying to play contemporary games, you're pretty much gonna have to run a PAL-based machine to have access to all the possible games and demos that are coming out today. Let's pop this chip in, and we'll take a look at some of the problems that I'm talking about. With the VIC-II chip installed and booted up, you'll notice here at my customized basic screen that there is one of the other problems with the original VIC-II chip in this machine, and it is jail bars. These are the subtly but very visible vertical lines you'll see on the entire image. There are many factors at play at what create this particular problem. I think part of it has to do with inside the VIC-II chip, it does control the timing for the entire motherboard. It's also handling the DRAM refresh for the entire motherboard. But also, if we pop this lid off here really quickly, some of the signals that run from the VIC-II chip for the video run up to the RF modulator here, and they run by some other traces on the motherboard that are going between the CPU and some of the other stuff on here, which I think all contribute to create those lines. There are all sorts of projects out there to create like a jail bar fixer. I think Clear Video is one of the names for those, and they work by introducing the same kind of noise into the video signal, and you can tune these little potentiometers to try to cancel it out. Personally, I've never actually had good luck with those, because for me, if you tune out the jail bars on this gray screen, then you're going to introduce them in some other color. And I can demonstrate that by using my Easy Flash 3 cartridge here. Let's pop this in the machine, and this has a very vibrant and colorful splash screen. For me, on this particular 64, the jail bars are the worst on the gray colors. Notice on the kind of light blue color around the Easy Flash logo there, you can't really see the jail bars. They're visible on the purple, they're slightly visible on the blue, but it's really the gray that's the worst. So when I use those Clear Video things, I would tune it where the gray actually looked good. It was nice and solid without lines, but then the blue and the other colors was much worse. I went ahead and I grabbed a Commodore 1541 disk drive because I want to try showing off a demo that is written for PAL systems that's not going to work. And it's the most excellent demo Lunatico. Lunatico? I think that's how you pronounce it, and if I'm mispronouncing it, I apologize for that. Demos like this talk directly to the disk drive, so you can't run them on something like a Kung Fu Flash here. These emulate disk drives in a way that works most of the time for software, but you really need to actually have a true disk drive or something like a Pi 1541 to use these. So we're going to use an actual floppy disk here, and on the system itself, let's start this up, and let's see how this works on an NTSC machine. Oh, well, look at that. It was designed for the new SID chip, and of course, I'm using the old one on this machine, but that's fine. I'm gonna hit space to run anyways. We should have sound. Okay, so it's too fast, and then the machine just froze. And that's not because of the SID problem. That is simply because this machine is not running in PAL mode. And that is just scratching the surface of problems you have running demos written a few years ago that push the limits of the 64 on NTSC machines. I went ahead and grabbed another 64. This is a 64G, which is a shortboard PAL variant machine. Hooked up to my RetroTink 5X Pro, there's no problem decoding the PAL color, as you can see here, but there's quite a good amount of jail bars on this machine. But let's insert this demo disk here into this floppy drive, and let's load up the demo and see how it should actually look. Now, this machine has a shortboard inside. Let me turn the sound up. This machine has a shortboard inside, so there's no warning about the SID chip because this demo is designed for this newer SID chip. But watch how this is going to work here. Ah, it looks like an Amiga. Look at that mouse pointer. It's drawing outside the borders, which you wouldn't think is possible, but it is with modern programming techniques. And there it is. There's the demo running. So that's how it's supposed to work. Up until recently, the only way you could run PAL software here in North America was to either convert a Commodore 64 you had to PAL by importing that VIC-II chip from Europe, changing the crystal oscillator out, which can be kind of expensive, or importing an entire computer like the 64G or any other PAL machine from Europe to North America, and then you're good to go. Well, both those options can be a little bit costly, especially buying an entire computer, but even getting a VIC-II chip is a bit of a gamble because A, you have to buy the correct one for the particular motherboard you have, whether it's a short board or a long board, and then also you might buy a chip that might work for another week and then die. I mean, who knows, right? It's always a bit of a gamble with these old machines. Well, the reason for me making this video is there's now a third option, and it's these boards right here. These are both Kawari 2's VIC-II replacements that use FPGAs to actually replace the entire chip. This is the Kawari Mini, and this is the Kawari. I guess it's the full-size one. I don't know if it's called what the actual name is, but I know the one on the right here is the Mini because obviously it's a smaller little board. Taking a look at it, you can see that it's got, well, pins to plug into the motherboard where the VIC-II goes. And if you take a look at the size of it compared to the original VIC-II chip, it's not, well, it's bigger obviously, but it's not hugely bigger. The full-size board is a little bit bigger, but there's a reason for that. It actually has a couple outputs on it. It has this one here, which I have connected to this ribbon cable. That's an RGB output for the VIC-II video signal. And then this small connector here, which looks like USB, is actually micro HDMI. Yes, this outputs, well, it's a DVI signal, but it's a digital video signal directly from your 64. The Mini version, on the other hand, doesn't have the RGB or the HDMI output. It just simply outputs the Chroma Luma signal exactly like the original VIC-II, which goes to your RF modulator and then out the video connector on the motherboard. This one also does do Chroma Luma output as well, just like this one. It's just that it has these extra options. So if you're trying to figure out which one to buy, well, if you don't need the RGB and you don't need the HDMI, then I recommend you get the Mini version. It's a little bit cheaper, and the functionality of these two boards, other than those two features, well, they're basically exactly the same. Installing the Kawari in your 64 is as easy as removing the original VIC-II chip, the dead one potentially, and you just put the new one right into the motherboard, and you're done. Both of these versions of the board were designed in such a way that if you still have the RF shielding on your long board, these chips will plug directly into the motherboard without any issue. There are some other cool and interesting benefits to using these boards. The entire clock circuitry of the 64 is done away with and is no longer necessary. So I could totally remove this oscillator from the board and the support circuitry, and the machine would still work perfectly. This is important because on certain versions of the 64, there's actually a little clock synthesizer chip that replaces this circuitry on the motherboard, and that chip often fails. You can get replacements for it, but you don't even need the replacement if you're using one of these FPGA replacement boards. Now, if you go back to what I was just saying about the PAL conversion of 64s, it requires you changing the oscillator and actually changing a jumper link that's on the board. Well, because this thing synthesizes its own clock signal internally, you can switch between PAL and NTSC on the fly. Let's get the ZIF64 reassembled here so I can demonstrate that. Turning on the system, you'll notice that it looks exactly the same. So you can see there's a red LED on the FPGA board, but it's actually looking identical. There's even jail bars. Now, those jail bars are not coming from the Kawari FPGA board at all. Those are being picked up by the traces on the motherboard that I talked about. Some of those timing signals run very close to the video signals. You can eliminate them entirely if you get an RF modulator replacement board, one like the one that Mark at TheRetroChannel designed, that's this board right here, and you bypass the video signals directly from this board right to this. That seems to resolve all the issues with the jail bars. Switching over to the Easy Flash cartridge, you'll notice the jail bars are slightly reduced versus how they were on the original VIC-II chip. So there is a little bit of a reduction because, like I said, there is some jail bar activity inside this chip itself here that's just not happening on the FPGA board. But if you think that putting this in will get rid of all the jail bars, well, it won't really. Of course, if you use this large size one and you hook up the RGB connection to something like a Commodore 1084, well, that will have a perfect jail bar free image because obviously this cable here is not even going through the motherboard at all, so you won't have any issues. Now, popping in the demo disk here, if we run this, it's gonna have exactly the same issue where the system is just gonna crash. Now, of course, this error is just because of the SID chip, and let's turn the speakers up. The music is faster than it should be, the pitch is wrong, and then the system just crashed. I have the latest firmware flash of the Kawari board, and I've been working with Randy, the creator of this board, and as far as I can tell, compatibility, at least with these versions of the 64, is pretty much 100%. Now, the only enhancement over the original VIC-II that I've talked about with the Kawari is the ability to switch between PAL and NTSC. There are actually more features than that and some really cool ones as well. But first of all, let's take a look at this switching of PAL and NTSC. So the original chip that this thing is emulating is a 6567R8, which is the exact same VIC-II that I was using in this board. We're inside the Kawari config utility here, so we can just select between which chips we want to use. 6569R3, that is the later variant of the PAL chip. There's the early version of the NTSC chip here, the 6567R56A, and then there's the R6569R1. The reason why this emulates the R1 PAL chip and the R56A NTSC chip is because both of those support less levels of luma versus the later ones, which has the side effect of changing the way some of the colors look. The brightness levels are a little bit different. This matches exactly how those original chips were from Commodore, and Commodore did improve the VIC-II chips by increasing the number of luma levels, which is how, well, most 64s that you've ever used are probably the version with the increased luma levels. So let's pick the 6569R3, which is the better of the two PAL chips, the one with the more luma levels. And we're gonna hit S, and we're just gonna simply power cycle the computer. And that's all it takes to get the computer running in PAL mode. I'm pulling out the Kung Fu Flash. You'll see here, there it is. We are now running in PAL. We have the bigger border along the bottom of the screen. And unfortunately, the color saturation looks a little bit less, but this is a problem I'm having with the RetroTink 5X. And notice I have the color turn way down. And that's because for some reason this thing on NTSC mode is producing colors that are way, way oversaturated. I have to go turn the color down. And that's even with the original VIC-II chip. I'm not sure what's going on with that thing, but that wouldn't happen with a normal LCD monitor. So with my NTSC 64 with no other changes but the Kawari plugged into it and configured to run in PAL mode, we can load the demo off this disk here, the Lunatico Demo. We hit run. We're still going to get the warning about the SID chip. And here is the sound running at the correct frequency and speed. And the demo should work. Let's see what happens here. Oh, interesting. All right, well, those little artifacts that it was showing there, that had to do with the color changes that I've done on my kernel. And it has nothing, let me turn this down, it has nothing to do with the actual emulation. That would happen if I had the same kernel ROM installed into the PAL machine. Anyhow, as you can see, the demo is working, and I can assure you, I've run through all these different demos, tons of games, and everything works perfectly with the Kawari. I went ahead and I switched back to NTSC mode by using the config utility. Let's exit out of this, and I want to show some of the other cool features that you can actually do with the Kawari. This particular utility here is called the Composite Settings Editor, and it actually allows you to change the color values of all of the colors that are built into the 64. With the regular VIC-II chip on the 64, those colors are fixed in the hardware of the IC itself. You just have 16 colors and that's it. But with the Kawari, you can edit the luma, the phase, and the amplitude of all of the colors. Now on this particular screen, if I hit the J key, there's actually a preset here for Longboard Adrian's Digital Basement. And I worked with Randy in creating these presets, and I actually used an oscilloscope to look at the exact signals that were coming out of this original R2 chip, the ceramic version I have right here, so that when I pick this, the way all of the colors are configured here are to be as close as possible to this particular chip. The original colors that Randy had created out of the box, I didn't think looked very good. They were undersaturated, and they just weren't an accurate representation of the way the actual real VIC-II chip looks. So now this is the default value, and of course, anytime you change these colors. Like for instance, I can change red here to be any shade of red I want, but all you have to do to go back to the original colors is just pick the preset, and there we go. Mark from the Retro Channel went ahead and created similar presets for the other 3 variants of the VIC-II chip, the 2 PAL variants and the R56 NTSC variant. So all of them have really good presets, and Mark and I worked together to make sure that we were using the exact same methodology, using the oscilloscope to take a look at the phase and the amplitude, which means if you use either version of the Kawari in your system, you can be sure that the colors you're going to be getting out of it are really accurate. The additional registers on this thing allow for some additional graphics modes and extended functionality that does add some coolness to the machine. But let's be honest, I don't think there's really anything out there that's programmed to use any of these modes yet. So there's not a whole lot of functionality there. It's just sort of cool that it's there. One of them is an 80 column mode, which I think you start by running this 80 column thing and then doing that. And there we go. Now we have 80 column color text on the VIC-II. You can see here it's taking advantage of the entire 80 columns in BASIC. So if you've ever wanted to run Commodore PET 80 column software on a 64 in full color, you can totally do that with the Kawari. On the demo disc for the Kawari, the first demo here is a rotating ball. Now this is using color cycling for the color palette to do that smooth animation. This is something that's not possible on the normal VIC-II because, as I mentioned before, those colors are fixed in hardware. But because all the colors are redefinable on this, well, software can freely redefine that, and then it can do color cycling as well, which can result in cool animations like this. So I think we run the Grogu demo right here. You'll see that it's going to load, and there it was. It loaded in the normal 16 color palette. It's changed the mode to 320 by 200, I suppose, and then it redefined the colors to those custom 16 colors to have a pretty nice image, something you definitely couldn't do on a normal 64. There's a picture of a horse in here as well. Looks like it's using 16 shades or some amount of shades of gray. And we have a split 320 mode, which I'm pretty sure, yep, there we go. It's using text mode and the graphics mode, and it's changing between them using scanline interrupts. And what you're seeing here is not switching between the Commodore 64 text mode and its own built-in graphics. The picture here is using the graphics mode on the Kawari, which has a separate frame buffer inside of the FPGA itself. I'm going to switch the Kawari back into PAL mode and power cycle the machine. And I'm noticing here the colors don't look particularly saturated. So I'm going to go into the comp edit program and I'm going to load the default values, J, and there it is, marks from the Retro Channel. And there we go. That fixed the problem with the colors looking a little blown out and not that saturated. Now if we exit out of this, yeah, that looks more correct now. So up until this point, the coolest thing in my opinion of the Kawari boards is the ability to switch between PAL and NTSC. That's just so useful to people here in North America who don't have easy access to those PAL machines. Here is a little LCD screen, and I reviewed this recently on the second channel, and this can actually show PAL, NTSC, different color systems without any issues. So if you plug this into the 64, it's going to work. You're going to get a color image. Not everyone has something like a RetroTink 5X, which is a pretty expensive device that converts from the composite video or the S-video out of this thing into HDMI to hook up to your modern monitor, TV, or whatever. There's going to be a subset of people, especially in North America here, who are going to want to use their 64 with a CRT. And the problem is, and I've talked about this a whole bunch of times, there pretty much are no monitors in North America, no CRT monitors that actually support PAL. The only ones that do are typically broadcast monitors like the Sony PVM I have on the bench here, and there's a couple other multi-format type monitors that can support it, but it's exceedingly rare. If you have something like a Commodore 1702, which of course goes with your 64, it's not going to decode any kind of PAL color, and you will just get a black and white image on your CRT when you switch your machine into PAL mode. Let me demonstrate. All right, so I have my camera pointed at the Commodore 1084 hooked up through the Luma Chroma, so S-video equivalent. And as you can see here in the demo program, all is looking really good. In fact, let's run the 64 colors little basic program here just to show off the standard colors. And I can assure you that switching back to the original VIC-II chip will look basically the same on this monitor. Now, if we go into the config utility here and let's switch over to the R3, we hit save and we exit out and we power cycle the computer, and that's it. We've lost the color entirely. Now I turned down the shutter speed on the camera to try to stop the rolling. And as you can see, this monitor has no trouble synchronizing to the 50 Hertz signal that's coming out of this, but we have no more color. If you have another monitor like a 1702, a North American one, if the picture rolls because it's at 50 Hertz versus 60, all you have to do is adjust the vertical hold a little bit and it will lock on without any problem. If we run the 64 color utility, well, there you go. Again, we see we have no colors. Now this is completely expected behavior. Let's just talk very briefly about the difference between PAL and NTSC. The real difference between those two signals is the way the color signal is encoded into the composite video signal. Even though we're using S-video here, the color portion of the signal is the same as in a composite signal, they're just separated out. The color encoding itself is still NTSC or PAL. The whole thing about 50 Hz versus 60 Hz actually has nothing to do with PAL or NTSC. It just happens that NTSC signals typically run around 60 Hz and that PAL ones typically run around 50 Hz. And if you recently watched my video on the BBC Master 128 Part 3, where I converted that thing to run in NTSC mode, it was running in a mode called NTSC 50. So it's NTSC color encoding, but with a 50 Hz refresh. The reason why that matters is because on the BBC, which happens to be sitting back there behind me, the normal graphics modes have more lines in them and more text lines as well than typical NTSC monitors would display. And when you slow down the refresh rate from 60 to 50, you gain additional scan lines. That's one of the trade-offs between 50 and 60 Hz. On the 64, if you have a PAL computer or you're running the Kawari here in PAL mode, those additional scan lines are kind of wasted. They're just added up to the border on the bottom and the top of the screen, and you don't actually get more active lines of image. The thing is, demos push the limits of the machine and they draw in the border region, and that actually means that sometimes if a demo does work or a game, it actually can cut off part of the image because it's drawing inside that border region, which on an NTSC monitor, well, has less lines than there are on a PAL image, so it just chops them off. When Randy, the creator of this project, hit me up about testing out his final versions of the boards, I asked him if NTSC 50 was actually possible. Because the FPGA is completely synthesizing the entire video signal, creating non-standard modes like NTSC 50 might actually be possible. And my keen-eyed viewers who have noticed me running this config utility may have noticed that there's actually an option for NTSC 50 right here. And if I hit the spacebar on that and I hit save, all of a sudden we have a color image on a North American monitor. It freaking works. I've actually done a good amount of extensive testing on this to see what monitors support this mode and which don't. And I found that pretty much all older CRT-based displays completely work perfectly with this mode. That includes all the different 1084 monitors, the Commodore 1702, and plenty of older CRT-based TV sets as well. Now, of course, I have no way to tell you if a particular monitor you have is going to work in this mode or not. Typically, the biggest roadblock for it working is whether that monitor can synchronize to the 50 Hz refresh rate. And I found that later CRT monitors actually don't seem to do that super well because of a setting that's usually in the service mode, as in Sony sets, or something that's programmed into the firmware. That Toshiba TV I have on the bench back there behind me definitely does not work at 50 Hz. The image rolls, and there's no way to fix that. It does show color with NTSC 50, so that part of it works, but it's not synchronizing to the signal. It seems that most or all 90s Sony sets have a setting in the service mode to enable it to synchronize to 50 Hz perfectly, and those work great. Check out the video I made on my little 9-inch Trinitron set that I modified for RGB. I talk about that particular setting in the service mode to enable 50 Hz mode. That's all you would need to change to use the Kawari like this with one of those Sony sets in full color while running in 50 Hz. So I have the floppy drive plugged back into the system, and let's try loading that demo, which should work perfectly now, other than the warnings we're going to get about the sound and that weird color issue because of the particular border colors I'm using in my BASIC. I have the sound hooked up to the TV or the monitor here as well, and yeah, it's going to work, and it's going to work great as well. This demo is amazing. I highly recommend, if you get one of these and you're in North America, get this demo working and check it out. So there it is. I'll turn the volume down on the monitor there. So yeah, this is kind of a killer app in my opinion. For those of us in North America, if you want to experience PAL-based software and demos on CRTs, on your original CRTs like the 1702, well, the Kawari makes it totally possible with this NTSC 50 mode. It's honestly freaking awesome. There is one small caveat I want to mention about this color mode though. If you hook up your 64 to the monitor using composite video, the dot crawl is going to be kind of shimmery and moving. The shimmering is not visible when you're running at 60 Hertz on the 64, and that's because the color carrier, which generates the dot pattern that enables NTSC color encoding, is all synchronized and locked to all the other frequencies of the video, frame rate and whatnot. So those little dots that you see around the text are solid and they don't move at all. But in NTSC 50, the color carrier is no longer locked to the frame rate, and that gives you this kind of shimmering effect with those dots. And that's just one of the unfortunate side effects of this hack of a video mode. It's not visible at all in Chroma Luma mode though, and that's because the color signal is separated from the Luma signal, so you're not getting that overlapping artifacting that you're getting with the composite video signal. Now, since I've shown off all the cool features of this board, you're probably asking, how do I get one of these? Well, first off, I want to say, and we're looking right here at the GitHub repo, that this project is open source, which is freaking amazing. Honestly, that just brings it to the next level of awesomeness. The Verilog code that runs in the FPGAs along with the PCB design files are all available on this repo, which of course I'll link in the description below, along with the utility software and all that other good stuff. And you can see here, Randy says the BOM or build of material cost is typically around $30 to $80, of course, depending on how many of these boards you're making at one time. I'm going to put a link in the description below to Randy's most recent update video on this project, and I think he's currently going to have some available for sale here in North America, but I'm pretty sure he's working with another reseller, which when I find out the right info, I'll link down below as well. That will allow you to buy these directly without having to make one yourself. Randy told me that the assembly process of these, because there's all sorts of SMD parts on these, well, it's a little fiddly, and he's just one person, so it's not ideal for a one person to be making and selling these. So that unfortunately means that these may be a little hard to get. But as far as I'm aware, there's going to be like a waiting list. So if you go to buy one of these and they're not available, well, there'll be a way to put yourself down on a waiting list. So when some get made, you can hopefully get one pretty easily. I'll try to put all the updated information I can find on where you can buy these down in the description below. So check down there for the most current information. There's tons of really good information on the GitHub repo, so I really recommend you read through that before purchasing one of these, just to make sure all the compatibility of how you want to use the Kawari is going to work for you. There's one other caveat I do have to mention, is that these chips are designed to work in 64 long boards. Compatibility with short boards, which use the later VIC-II chip, it's not perfect. Commodore changed the way the reset circuit works on those machines, and that causes some issues. I've done some testing for Randy, and I think a bunch of other people have as well, and it can work. It's just that some of the timing can cause issues, and you can have problems where when you power cycle the computer off and on, the video output might not initialize properly, and other little issues like that. There are also some fitment issues inside the short boards, just because the case is so much more compact, at least from a vertical standpoint, that I'm not sure it actually fits in there perfectly. But your mileage may vary on that. I just wanted to point out that there might be some issues there. Randy's latest video that I've mentioned already talks about some of these compatibility issues, so make sure you watch that first before you do any purchasing as well. As you can probably tell, I'm really freaking excited about this project. I absolutely love this thing. I've had these things for a few months now and have been using it off and on all the time, and it just rocks. For me, the biggest benefit is being able to use my 1084 monitor right here, which is the one I usually have floating around, with the machine running in PAL mode, so I can check out all the super awesome games and demos that are coming out for the 64 without any of the compatibility issues that you normally experience here in North America. That feature alone makes this thing a great replacement, even if your machine has a working VIC-II like this one does. Now, I breezed over a bunch of the other capabilities of this thing, has some acceleration stuff and some other things it can do. So definitely check out the GitHub repo so you can read up about all of those things, and check out Randy's video where he goes over some of those cool new features as well. And I guess that's going to be it for this video. So I hope you enjoyed my look at the Kawari here. Well, the mini one, but the maxi or the big one here works exactly the same way. And if you thought this was interesting, I'd appreciate a thumbs up. But if you didn't, you know what to do. Definitely put your comments down below in the description if you have any thoughts or suggestions about this. And of course, you can reach out to Randy on the GitHub repo, open up issues and stuff like that if you have any suggestions there. I mean, it's open source, so if you maybe want to contribute to the project as well and enhance the firmware to expand the capabilities of these things even beyond what they can do now. Of course, I want to say thanks to my patrons. Their names are going to be scrolling up the side of the screen. Patrons get early access to videos, stuff like that. If you want to become a patron, you can do so at the link in the description below. And I guess that's going to be that. So stay healthy, stay safe, and I will see you next time. Bye.